So of course it gets more complicated than that general anatomy. We're going to look at the 5 types of vessels and the specific anatomy and histology of each one. There's actually also 2 types of arteries. There's going to be elastic and muscular arteries that have slightly different compositions of, guess what? Their elastic and muscular tissue. So first, some terminology. We're going to be talking about the size of these vessels and talk about both the thickness of the wall and the diameter of the lumen. So let's make sure we all know what those things are. The lumen is the space in the hole in the middle, right, where blood travels through. That hole is the lumen. So the diameter is that across that area there. The thickness of the wall is also what it sounds like, right? It's the thickness of the wall. Those tunics. So how thick are those tunics that make up the wall? So let's actually start with those sizes. And generally the idea is we're going to go from big here, both wall thickness and lumen diameter, to small and back to big again. Let's get a little more detailed than that. I'm going to actually give you some numbers to give you some context of these things. So first, let's do wall thickness. And you maybe have some thoughts already, like, well, I told you big, right? So wall thickness, we're going to start at 1 millimeter. That's the thickness of the walls surrounding those arteries. Of course, there's variability, right? This is not all arteries because there's different sizes of arteries. They branch, they go from elastic to muscular to smaller before they branch into arterioles. Arterioles are going to be 6. Wait, let me make sure I got that right. Nope, actually, we're still at 1 millimeter. So not a whole lot smaller. Eventually, oh no, I did that wrong. I'm sorry. I had it right, 6 micrometers. To get from 1 millimeter to 6 micrometers, there's going to be transition. So there are arteries that are 0.5 millimeters. Remember, micrometer is 1,000th of a meter. Then we've got capillaries. These are going to be, thickness is 0.5 micrometers, even thinner, back to 1 micrometer. So still a lot smaller than those arterioles, and then 0.5 millimeters. So we never get quite back as thick as arteries. So kind of one key thing about this, and it's related to their function, is that arteries, the walls of arteries and arterioles are a little thicker than veins. And that goes with that picture you saw in the last PowerPoint. You could see that. Veins are more floppy, there's less to them. They don't have as much integrity and stuff holding them together. And that's actually related to their function as well. Lumen diameter, that is the hole in the middle, and this is going to vary as well. So in the arteries, we've got 1.5 centimeters. That, you get out your ruler, right, and look at that. That's a decent chunk. Of course, aorta and a cow, you saw that. That's even bigger. It's probably 1 inch. But this would be kind of average arteries and not a cow. We're not as big as cows. So our aorta is not as big as a cow aorta. Arterioles, we're looking at, you don't need to know this exact number, 37 micrometers is what I have written down. So micrometers, a lot smaller. And again, there's progression to get there. Capillaries, 9 micrometers. Interestingly, that's just a little bigger than a red blood cell. So red blood cells are between 4 and 7 micrometers. So red blood cells can just barely fit through capillaries. Isn't that convenient? Venules are going to be back big again, 20 micrometers. These are about the same, right? I'm not going to ask you to compare the lumens of the arterioles and the venules to me. And then finally veins, we've got for diameter 5 millimeters. So not quite as big as our arteries. And then of course, we're going to get back to when we get to the vena cava, it's going to get bigger than that again. Okay. Let's keep going and look at the composition of different tissues for these. So let's start with arteries. Arteries are going to, there's 2 different types. They're going to have either, let me do one thing here. They're all going to have a thick, what do you think? Tunica media, both of these. For elastic and muscular, it's going to be a different, slightly different thing. For muscular, we're going to have a thick, smooth muscle layer. Actually, for elastic, I'll keep doing this. Elastic, we are also, but we're also going to have some elastic in there as well. Make that purple is often how elastic is shown. So I'm going to add some purple into this inner layer here. That doesn't look like purple, but it is. Elastic fibers are actually kind of embedded in there, in that tunica media. Pretty decent size oh my gosh, tunica externa. That fibrous layer. You remember from the cow heart, these things had some integrity to them and thin endothelium, just like all vessels. So pretty much the endothelium is not going to vary because it's simple squamous. It's always simple squamous. Endothelium is that tunica interna, right? I'm actually going to draw that just the same in all of these, the same size. Well, actually, sorry, not same size, but same structure. It's going to get a little smaller in capillaries. How do we know? Because that was this. Go back a little bigger. Again, I'm not drawing these exactly to scale. I'm just trying to draw the tunica into the endothelium in all of my pictures. In the arterioles, they're a little thinner overall, right? But we still have a decent muscular layer, and that's important for their function. And I can't control that exact thickness with this. So I'm going to do that, even though it might be a little thinner muscle than that. The muscle is really important in this arteriole. So I'm still going to draw it like that. And then we're going to have our tunica externa. Not quite as thick as in our arteries. The whole thing gets smaller. Smooth muscle is still a very important component of the arterioles, and that's going to be important for its function. They're going to be able to constrict and dilate. Capillaries, we're done, right? That's it. Venules. Basically, we have a thin, so that's starting down here, thin tunica externa and a thin tunica media. Those should all be touching in reality, right? I'm going to label this one tunica media as well because it looks like a different color. It's red in both cases. The red looks darker here. As we get to veins, basically the same idea as our venules, but we're getting a little bit bigger. Again, a little bit more smooth muscle than our venules had. Let's color this in. Let's just color these in too, just to make it consistent. All my smooth muscle is this dark red now. This one is, but I want to leave my elastic fibers in there. And then the veins, the other thing that's key about them is they have a thicker tunica externa. So I think I will just draw this with the same color. Otherwise it looks like it's a different color. Nice, thick tunica externa, which is floppy. Connective tissue it's supportive, but this is collagen fibers. It's like your skin. It's not like bone or cartilage. And this is that floppy stuff that makes the vein floppy. It's not as rigid as muscle or elastic tissue. So that's the basics of these vessels. We will see why these structures all matter. Some of them you may have some ideas already, but so know them.